Alright guys, in this lesson we're going to talk about section 7.4, which is similarity in right triangles. Now in section 7.3 we talked about similarity in normal triangles and those shortcuts, which were AA, SAS, and SSS. But today we're going to talk about what specifically happens if my triangles are right triangles. Because as we've seen before, triangles are special, right triangles are even more so. We have one vocab word to start with. Let's go ahead and get started. Geometric mean. Geometric mean is a value x, where x is both means of a proportion, as shown here. Remember, the means is the second and third number in the proportion where they're diagonal from each other here. A geometric mean is a proportion where the mean is the same. So the mean is the same exact number. Our extremes are different. They could be the same, they could be different. And what happens is we end up getting that the mean, x, is equal to the square root of a times b. The work for that is shown here. Here's the proportion where the mean is the same. If I were to cross multiply, x times x is x squared, a times b is ab. Solve for x by taking the square root of both sides. Now in the last lesson we talked about how to simplify square roots. We are going to be utilizing that in today's lesson. As you guys are finishing writing this down, please feel free to pause the video at any point if you need more time on a question or a concept, or to rewind the video if you need to hear something once again. We're going to go ahead and move to our first theorem. Our first theorem says that the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to each other and to the original triangle. So there's a lot of wording here that might be confusing. So let's break this down into what it's saying. It's saying that if ABC is a right triangle, which it is, it's shown by the right angle here, with a right angle named here at C, and an altitude CD. Now altitude is if I draw a line straight down at a 90-degree angle, so it's perpendicular. If I have a right triangle that has an altitude drawn from the right angle to the opposite side, then you create these three triangles. You have the large triangle here, and then you have the small triangle here, and you have the medium triangle here. What this theorem says is that all three of these triangles are similar to each other. Now this only happens on right triangles. Because I'm splitting this right angle down the middle at a right angle, we end up having some common angles and some common sides happening here. Now one main concept of today is going to be recognizing how do these triangles relate to each other, what parts are corresponding, what angles are equal, what sides are proportional. All right? So let's go ahead and get to those proportions. So corollary 1. Okay, so we're still talking about that previous theorem, but we are talking about some extensions. Our first extension says that the length of the altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the segment of the hypotenuse. So keep in mind they're talking about this large triangle here. They're saying that the altitude of the large triangle is the geometric mean to each segment of the hypotenuse. So remember, this is the hypotenuse, this is the altitude. What this theorem says is that the altitude is the geometric mean of each part of the hypotenuse. So I'll call this part 1, I'll call this part 2. So in segment language, if I have a proportion relating this triangle, then the altitude is the geometric mean, meaning CD is the mean of both proportions. And it's the geometric mean of the hypotenuse parts, which is AD and DB. Okay? If you'd like to think about this in words instead, think about that the altitude is the geometric mean to the first hypotenuse part and the second hypotenuse part. And that's because they're similar. Okay? Because all the triangles in here are similar, these are the parts that are matching up. The first hypotenuse part is corresponding to the altitude of the large triangle. The altitude is corresponding to the hypotenuse part too. Our second corollary is something similar. The length of each leg of a right triangle. The legs are AC and CB. So those are the legs they talk about. The leg is the geometric mean of the hypotenuse and the adjacent part of the hypotenuse. So as another reminder, AB is my hypotenuse, and these were the different parts of the hypotenuse. What this corollary is saying is that the leg is the geometric mean of the entire hypotenuse and the closest part of the hypotenuse. So if I wrote, let's focus on leg 1. Okay? So if I write a proportion using leg 1, this leg is a geometric mean, meaning that it goes in the corners, AC, AC. It's the geometric mean of the entire hypotenuse, which would be AB, and the closest part of the hypotenuse. Okay, if you look at the hypotenuse, the part of it that's closest to leg 1 is this part here, which is AD. Okay, so the leg is the mean of the hypotenuse and the adjacent hypotenuse part. Okay, the other leg, if you're looking at that other leg, which is here, that leg, which is CB, is the geometric mean of the entire hypotenuse, which is AB, and its closest part, which would be DB. There's a lot of wording here. There's a lot of practice here. My rule of thumb is that the similar pieces are always going to match what it touches. So the altitude is the geometric mean of the hypotenuse parts that it touches, which is both. So both parts get put into the proportion. The leg is going to be the hypotenuse that it touches. It touches the entire hypotenuse and just this part. So those are the parts that go in with the leg. We're going to start practicing this on the next page. Feel free to go back and rewind if you needed a repeat of any of those proportions. Let's go ahead and look at problem 1. What is similarity statement can you write comparing the 3 triangles in this diagram? So to be able to do this, we need to relate the big triangle EAK, the triangle here EAG, and the triangle here AGK by writing a similarity statement where everything is in order. So let's go ahead and start off with this first big triangle. You can name that in any way you want. I'm going to name it EAK. So that's my big triangle. Now what we need to do from here is name the other 2 triangles in the same order. So starting off with the small triangle, which point matches E to A? Okay, because we're going to go from E to A on the big triangle. How does that match on this triangle? Okay, so notice how I went across the diagonal first to my right angle. Sorry, this is not the diagonal. I went across the small leg first to my right angle. So take a look at just this triangle. Which side is shorter, EG or GA? You should be thinking that EG is smaller, where G is the right angle. So E will match E, and then G will match A. Another way you can think about this is that this angle E on the big triangle is the same exact angle on the small triangle, so they have to be in the same spot. G is my right angle, so that's going to match the right angle A, which leaves my third point on that triangle A as my last letter. Now look at the small triangle, or sorry, the medium one. Okay, we're going to match angle E, then angle A, then angle K. Now you might notice that angle K is going to match exactly, so that's going to be my last letter. My right angle is G, and that leaves A in the same spot as the first letter E. Okay, you want to look for what angles are definitely going to match, where are my right angles, and this might take a lot of practice for you guys to get completely true. Okay, question 2. What is the geometric mean of 5 and 12? Now this one asks about the geometric mean. Remember, geometric mean means that you have a proportion where the number in the means is the exact same. They're asking, what is that number? So that's our x. Okay, what goes in these other two spots? Well, that's going to be 5 and 12. Now take a look at what you have here. You can solve this using cross multiplying. X squared equals 5 times 12, which is 60. Square root, both sides. X will be the square root of 60. Now remember, we don't like using decimals anymore, so we are going to go ahead and utilize what we learned in the last lesson on how to simplify square roots. You can use perfect squares, or you can use a factor tree. You should be getting 2 root 15 as your answer. Okay, remember we are simplifying this using the skills we learned in the last lesson. All right, so now with questions 3 and then 4, we're going to be getting into that main concept of today, is how to use geometric means to solve for values of right triangles. So we're going to solve for x and y here first. Now remember, there was 2 different relationships that we learned about. 1, that the altitude is the geometric mean of the pieces of the hypotenuse, and 2, that the leg is the geometric mean of the entire hypotenuse and its most closest part. We need to find for x and y. So let's set up a proportion for both, starting with my altitude. Okay, the altitude, 6, is the geometric mean, so it goes in the corners. It's the mean of the pieces of the bottom hypotenuse. So remember, this is hypotenuse part 1, this is hypotenuse part 2. So 2 and x go in those spots. Can I solve this proportion? Yeah, I only have one variable x. I can totally solve that. Let's go ahead and do that real quick. I'm going to cross multiply. 2 times x is 2x. 6 times 6 is 36. Divide by 2. X equals 18. Awesome. So now this value here is 18. If this is 18, how much is the entire hypotenuse? You should have said 20, since 2 and 18 make 20. Now let's go ahead and look at y. Y is a leg. So remember, legs are also geometric means. So y will go in the corner. The leg is going to be the geometric mean of its most adjacent part, which is x, or 18, and then the entire hypotenuse, which is 20. So we are going to go ahead and solve this by cross multiplying. I get y squared equals 360. We're going to solve for y by taking the square root of both sides. Y equals the square root of 360. Now, if you put this in your calculator, you are going to get a decimal. So we have to actually go ahead and simplify this using what we learned in the last lesson, just like we did with the square root of 60 before. You should get, when you're done, 6 square roots of 10. Okay. Now, here's our last question. What are the values of x and y? So the first thing you want to ask yourself here is, x and y, are those legs or is that an altitude? They are both legs. So we are going to use the leg proportions. Now I want you to go ahead and try to write the proportions on your own without my help. Go ahead and pause the video and write the proportions now. All right, coming back. For x, you should have x as your geometric mean with the numbers 16 and 28 as your extremes. Now the reason why we have 28 here is because the entire hypotenuse is 12 plus 16. Okay, your proportion for y should have y in the corners because it's a leg, it's a geometric mean, with 12 and 28 in its corners because it's the adjacent hypotenuse and the entire hypotenuse. From here, we're going to cross multiply, and solve. Now again, I want you to pause and try to solve this on your own, okay, before we go over the answers. So go ahead and pause now. All right, hopefully you have had your answers. X is going to be 8 root 7. Y is going to be 4 root 21. Okay, this is a very difficult lesson. I want to be very clear with everyone that I understand that this is very complicated. So I'm going to go ahead and upload an alternative video to this from Khan Academy or from YouTube that I think might be helpful if you need a little bit extra support. Go ahead and get started working on your 7-4 homework that you should all have. Okay, thank you.